Let us look at this problem matrix rotation. So we have to rotate the matrix 90 degrees clockwise. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we have to rotate it 90 degrees clockwise. So this is the clockwise direction. So rotation in that direction means that this 7 would come here, 7 would come here, 8 would come here, 9 would come here, right? Then 4, 5, 6 would come here, 1, 2, 3 would come here. So this is the matrix rotation, 90-degree rotation. Now let us look at the another example. 1, 2, 3, 4, 5, 6. 90-degree rotation would be 5, 6, 3, 4, 1, 2. Okay. Now matrix rotation can be simplified, can be broken down into two simpler operations, which is taking the transpose and reversing each row. So now let us look at how we can take the transpose in both these cases. So this was 90-degree rotation, transpose. If we take transpose of this array, we have 1, 4, 7, right? So this entire row becomes the column. It's shifted like this. Then this wait, I just said the wrong thing. This entire column is shifted to become a row. Okay. Then this entire column is rotated to become the second row. So 2, 5, 8. Then okay, 2, 2, 5, 8. Then this entire column is shifted to becomes the third row. Is rotated to become the third row. Now this is the transpose that we have taken. Now if we take the reverse of each row, we will take reverse of each row, then we would get 7, 7, 4, 1, right? 7, 4, 1. 2, 5, 8 becomes 8, 5, 2. 3, 6, 9 becomes 9, 6, 3. And you can see that these two are matching, right? Since these two arrays are matching, so this 90-degree rotation can be broken down into two operations. Now let's see how this works with this second example that we have. We would take the transpose, then this 1, 3, 5 becomes the first row, 1, 3, 5. First column becomes the first row. Second column becomes the second row, 2, 4, 6. Then we perform the reverse operation on each row. So 5, 3, 1, 6, 4, 2. And you can see that this matches this 90-degree rotation. So performing these two operations will actually give us our answer. Now let us look at the code. For taking the transpose, we just have to do result of ji equals to matrix ij. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9. So as you can remember, what was the transpose of it? 1, 4, 7. You make this entire column as the row, first row. 2, 5, 8, and then 3, 6, 9. Now let us look at like how from this matrix to this matrix we can like how we can go from that matrix to this matrix. So uh, how we are doing it in code is we are assigning ji to ij. It means we are just Okay, so right. So what we do is, this is the result array, right? This is the result. So we have 0, 0, 0, 0, 0, 0, 0, 0, 0, right? So for 0, 0, comma 0, first do 0, comma 0. So this 0, comma 0 is initialized at 0, comma 0, like there is no switching. So we just write 1 here. Then I equals to 0, j was 0. Now in next step j becomes 1. So this 0, comma 1, this 0, comma 1 element is assigned to 1, comma 0. First row, 0th column. So this 2 is assigned here, right? Then j is incremented, j goes to 2, 0, comma 2 is assigned to 2, comma 0, which is 3. So 2, comma 0 is the second row, 0th column. Now can you see this, that this entire column is like this entire row is assigned to this column, right? So this is we are like, this is matching our transpose, right? We can also take transpose like this. We change this row into this in this column. We change this row into second column. We change this row into third column. So we can also take transpose like this. So this is what we are doing here. Okay. Now we are at then we increment I by 1 because j has we have processed j for second index, last index. So I becomes 1, j becomes 0. So now we are looking at this for where it will go 0, comma 1. So 0, 0th row and first column. So 4 goes here. Then we look at 1, comma 1. It is 5. So 5 diagonal elements are placed at the same place. Then we look at j becomes 2, 1, comma 2 is 6. So 2, comma 1. Second row, first column is assigned 6. Then I is incremented to 2, j is 0. So 2, comma 0 is 7 and 0, comma 2 we assign 7 right here. J is incremented by 1. So now we assign first row and second column. So 2, comma 1 is assigned, 2, comma 1 is assigned at 1, comma 2, right? So this 2, comma 1 second row first column, it is assigned at 2, comma 1 second row first column. Oh wait, did we do anything wrong here? Second row 0th column, j was 0, so second row 0th column, so 0, comma 2, and then second row first column, second row first column, it is assigned to first row basically so one row, row where I will be 1 and j would be 2. Yeah, so this is correct. And then we will go on to I2 j2. So this 9 is assigned at the diagonal element of it. So you can say that this matches a transpose. So this is how we take the transpose, and then we just reverse each row. So this, after taking the transpose, we have taken the transpose, we just do 7 for 1, 7 for 1, 2, 8, 5, 2, 9, 6, 3. And this is the rotated matrix that we were looking for. This one. Okay, so this was the solution. Bye bye.